Hi, Dominic. Welcome to the 100X Show.
Thanks for having me, Mehdi.
It's my pleasure. So, Dominic, before we start and jump into what Internet Computer Protocol is doing, I would love to know more about your background and the aspirations that led you to found Internet Computer.
Yeah, so I'm what you might call an engineering entrepreneur. So, I've been an entrepreneur for many years, but I'm very product focused, and I've created all kinds of things over the years. The .com era, I was actually working on what would have become one of the first sort of cloud computing services called smart drives that used sort of differential compression techniques to send files over what were then very slow internet connections. People were still using dial-up. More recently, the last thing I did was create a computer game, an MMO, massively multiplayer online game, which was primarily played by sort of kids in the sort of 8 to 14 age range. But, you had girls, teenagers, everyone playing. That grew to a little north of 3 million users. And what was very interesting for me with that was that it made the first production application of a decentralized database called Cassandra. I was sort of involved with that early on. And it used a horizontally scalable game server called Starburst that I designed. So, although it was a game, the scaling technologies behind it got me back into distributed computing. And, when Bitcoin started really taking off in April 2013, getting a lot of mainstream coverage, I was, like everyone, fascinated by the Bitcoin white paper, but also just drawn to the opportunities of that could come from, making crypto faster and more scalable. And I'd had some, prior exposure, I suppose you could call it that, to some of the thinking. Back in 1999, when I was working on the smart drives thing, I'd created my own sort of certificate authority for this tech using a C++ library called Crypto++, created by a guy called Wei Dai. And his website's actually still up there, and I believe he's still updating Crypto++. It's a fantastic C++ library for people who want to, put cryptography into their systems. Anyway, he had a paper called B-Money, which described ideas, I think, that you can see in Bitcoin, appearing in Bitcoin, many years later. So, something just, when I was looking for a change from the game and saw Bitcoin and just fell in love with the whole crypto thing.
Yeah, that's very interesting. So how do you, before I jump into the Internet Computer Protocol, I just learned that your background, you initiated with gaming. So how do you kind of see the landscape of crypto gaming, blockchain-based gaming at the moment? Do you think, are we still very early? Is it different from where your vision was when you were trying to work on a game? Can you just touch upon that a bit?
Well, back in 2013, I was in a very different position than I'm in now. I've spent years working on the technologies that make blockchains run. My ambitions were more modest in 2013. By the end of the year, I wanted to create a cryptocurrency called Gamecoin. I think I had the domain gamecoin.org at that time. And the idea was that computer games could sort of support this new cryptocurrency, and that would make it possible for virtual goods to be bought and sold within their environments, and the value transferred between games. So I wanted Gamecoin essentially to support a virtual goods economy that would, unite different games and the whole games ecosystem. So I suppose in some ways it was very forward-looking. I was imagining something akin to what's beginning to happen now. Anyway, if you've ever built a game, and especially a MMO with millions of users, you quickly become aware of quite how much data is involved and how many transactions would be required to support that kind of activity. So, I started out looking at existing attempts to speed up blockchains and so on, and hoped I could just adapt them and get Gamecoin up and going, up and running quickly. I soon realized, however, that that there wasn't really any technology about at the time that would meet the needs of this thing. So in 2014, I just dedicated myself to working on something very technical called fully leader-free asynchronous Byzantine fault-tolerant consensus, and some of the applied cryptography associated with that, and came up with another plan for a blockchain that would have been called Pebble. Somewhere out there, it was never released, but I think it did get out. There's like a 100-page white paper for this thing called Pebble. But around that same time, I got introduced to Ethereum, which of course hadn't, it was just a project at that stage. It wasn't a running network. And, I became fascinated with this idea of a world computer. Now, the concept of a world computer has really sort of been forgotten within the Ethereum ecosystem because, very clearly Ethereum can't play that role. It just doesn't have the capacity. But I became absolutely obsessed with this idea of creating a blockchain that would be fast enough, efficient enough, infinitely scalable, and have functionality, for example, that would allow blockchain code, smart contracts to serve web, that a blockchain, this advanced blockchain, really could play the role of a world computer. Sooner or later, I had this project called Dfinity going, and I was thinking, about ways that you could apply cryptography and distributed computing techniques and so on to new techniques generally to create a world computer. And I think my original hope was that the ideas would be used to create an Ethereum 2 or 3. But after a while, it became apparent that it would require a new project because building a world computer would take years and require building out a very large R&D capability, which would make it possible to, for example, develop completely new forms of cryptography to support, to solve the specific challenges if you want to create a world computer, and that it would take a very long period of time. So eventually, there was an incubator called String Labs in Palo Alto, which I was part of, and it took on the Dfinity project in 2016, and we started hiring some people, working on prototypes and so on. And the Dfinity Foundation is a not-for-profit. It was created in Switzerland, a place called Zug, originally in October 2016. Dfinity Stiftung. It's now in Zurich, actually, but it started in Zug. And then I think the internet, what was now the Internet Computer Ledger, was created, I think, January 2017. And vast majority of that ledger was assigned to the foundation, and then the foundation ran a public crowd sale, decentralized crowd sale, where people could swap Bitcoin and Ether for what were then DFM and now ICP. And back then, the price was just three cents, and it was a much more sort of innocent time, and most people in the industry back then really were there because they believed in the social impact or potential social impact of blockchain, and were very passionate about the technology. And in our it was called the seed round in our public crowdfunder, we said we only wanted to raise $1 million. We were marking Ether and Bitcoin to market. We only wanted to raise $1 million. And once that target was met, the systems were designed so they'd automatically shut off after 24 hours. By reached the 1 million point. It was Swiss francs, not dollars actually, and we reached that pretty quickly. And the countdown to 24 hours began, and by the time the systems had shut off, we'd raised 3.9 million Swiss francs in Bitcoin and Ether. And what was interesting was the amount of Bitcoin and Ether coming in was accelerating. And no doubt, had we left that seed round open for a week or something, we probably would have collected 100 million Swiss francs. But, that was us. We weren't aiming to collect huge amounts of money, and it switched off. But I think in many ways, though, we kicked off that ICO boom of 2017. So, people were watching what happened. And, for example, Tezos then ran this crowd sale that instead of running for 24 hours, ran for a full month. I think they collected $300 million or something. Then, of course, EOS was watching that. And in the summer, they launched a crowd sale that lasted for a full year and collected $4 billion. And, the rest is history. But although we only collected a much smaller amount of money, the price of crypto is rising all the time. So as we're, selling it off, even as we're selling it off, so we ended up, I think, about 20 million or something like that. I don't know what it was. And it was enough money for us to expand our R&D pretty aggressively early on. And then in the following year, in 2018, we ran 2 more rounds, a strategic round and a pre-sale round. And owing to the way that the sort of regulations were changing and so on, and the legal landscape, we ran those with VCs and hedge funds. But that raised another sort of 110, 20, and then some commitments to this fund that would invest in ecosystem projects. And that was sufficient for us to get the internet computer built. And it took several years. I mean, we've been working on this relentlessly. And by May 2021, when the network finally underwent Genesis, we had more than 200 people working the project. The vast majority of whom are research, very senior researchers and engineers, with a large portion of those researchers being cryptographers. And since then, there's been a lot of market volatility and craziness. But I think if you look at the even now, I think my view is the markets are pretty down from where they really should be. But that's not financial advice to anyone listening. But it's obviously been provided members of the public who got in 2017 with a very handsome return, sort of 1,000x.
Dominic, one thing I wanted to unpack that you highlighted at the moment was can you just give me an overview of how Internet Computer Protocol works and how is it different from Ethereum and other layer ones? Because the problem you're trying to solve is much more grander. So what kind of approach you are taking in order to solve that problem? I think would be very interesting for our audience.
Yeah, so I'll try and keep it simple. If you want to build a rocket ship, you're going to end up doing some more complex engineering. And if you want to build a world computer blockchain, you're going to end up doing some, much more complex science and engineering. And that's just the way it goes. And so, a lot of the science and engineering involved, can be understood at length. And, if you go to Dfinity.org, there's a how it works section. You can really dig in. But it's certainly non-trivial. It's not like, back in the day, if you read through the Bitcoin white paper a sufficient number of times, by the end of it, you understood how Bitcoin worked. The Internet Computer Blockchain, has a lot of, for example, new cryptography, and that can be difficult to get your head around if you're not a cryptographer. But I'll give you a sort of simple overview. It's not proof of work. It's not proof of stake. It has elements of both. Unlike other blockchains, it doesn't really run in the cloud. You can't have cloud validators. The network's hosted by these things called node machines, which are hardware built to a specific spec. Node machines are run by independent owner-operators from data centers around the world. And these node machines connect together using the ICP protocol, which stands for Internet Computer Protocol, which is where the ICP token gets its name from, and create a blockchain that is what we call web speed, has web levels, of efficiency, is infinitely scalable, is capable of serving web, so smart contracts hosted on the internet computer, blockchain code, whatever you want to call them, canisters, can actually directly serve interactive web content to users, and a host of other things. Inside, if you were to sort of lift the bonnet of the internet computer, inside you'd see these things called subnet blockchains. And what's very cool is that these subnet blockchains are powered by something called chain key cryptography. And we'll probably return to that because, one of the many interesting features, that are going to be hopefully adopted by the network in the next few weeks is Bitcoin integration. And chain key cryptography actually powers that too. But chain key cryptography is also how this whole network runs today, and why it's so fast and why it's able to scale infinitely. So these subnet blockchains can interact with each other directly without actually seeing each other's blocks. And that's because chain key cryptography enables the blockchain, if you like, to create signatures on its responses. So if you ask it a question like, give me a copy of this data, or if you call a function in a smart contract, the response can be signed by the blockchain itself using this chain key cryptography. And all you need to do actually is just validate the signature. And that will tell you not only that your interaction with the blockchain hasn't been tampered with, but also, most importantly, that the state of the blockchain, i.e. all of its data, that's what the state means, is correct. It hasn't been messed with, essentially. So to understand why this is important, if you look at a blockchain like Ethereum, I think the blockchain is several terabytes in size, but I don't remember the state. But the way you're supposed to validate your interactions with Ethereum is to run something called a local node. And this local node will download all the blocks of the Ethereum blockchain and replay all the transactions inside to recreate the state locally. And now you can interrogate that state. And because you know that your local node will have downloaded the blocks according to, in a way that allows it to be sure that it's got the right blocks, you can now trust that. When you've replayed all the transactions, you can trust the state. Now, the challenge with that, of course, is you've got to have this local node. You've got to run it yourself if you want full security. And it's going to download certainly hundreds of gigabytes, perhaps much more, of blocks. And then when it's downloaded them, it's got to replay the transactions inside. And, for that reason, it can even take you a week to get an Ethereum local node up and running. So that's why, for example, there's this company Infura that runs lots and lots of Ethereum local nodes on Amazon Web Services. And if you want, you can trust Infura and just interact with those local nodes. But as you can see, this is quite expensive. Actually validating your interactions with blockchains that work like that is quite expensive. You got to download all these blocks, and then you've got to replay the transactions inside to recreate the state, the data of the blockchain. With chain key cryptography, you don't need to do any of that anymore. All you need to do is to send your query to the blockchain and check the signature on the response. And you can check the signature using the blockchain's chain key, which is 48 bytes. Now, as it turns out, naturally, the internet computer's got a master chain key, and it actually belongs to a special subnet where something called the network nervous system runs. And the network nervous system's essentially an advanced DAO, a decentralized autonomous organization. It's much more sophisticated than any other DAO in existence. And this DAO, of course, this network nervous system, really exerts the will of the community, but algorithmically. And what that means is that anyone in the community, anyone listening can do this if they like, can acquire some ICP tokens and stake them inside the network nervous system to create what's known as a voting neuron, which, as the name suggests, allows you to vote on proposals. And when, again, it's completely permissionless, anyone can put proposals into the network nervous system. And when it adopts a proposal, which it does through a complex process, I won't get into here, but when it adopts a proposal, that proposal is automatically executed by the whole network. And for example, this network nervous system DAO can create new subnets. It can upgrade the protocol by changing the software image that's running on the node machines, and all kinds of other things too. And actually, it's already processed many thousands of proposals. Some of them relate to kind of Oracle information, but a lot of them relate to just network management. Forming new subnets for existing nodes or upgrading the protocol. You might think, well, why on earth would I want to get involved with something like that? I'm going to have to vote on all these proposals to get my voting rewards. Well, luckily, what you can do is you can configure your voting neuron to vote automatically by following other neurons. And of course, you can specify what other neurons you want it to follow. So essentially, the network nervous system DAO is a kind of liquid democracy where trust and expertise can be delegated on the fly. And it allows the whole internet computer blockchain to be self-directed and adaptive. So, I can't give you the number, but I would imagine the protocol's probably been updated, way more than 100 times during the time it's been running. So that's very different to traditional blockchain. So anyway, this network nervous system subnet has this sort of master chain key, if you like. And then when new subnets are created, they get their own chain key. But those chain keys are signed by the network nervous system. So hierarchically, everything, goes up to this master chain key. And so you don't need to download anything. You can write some software that directly interacts with the internet computer blockchain, and just check this using this 48-byte chain key. Just check the signatures on your responses, and that will, tell you not only your interactions haven't been tampered with, but that the blockchain itself hasn't, been tampered with, and everything's running correctly. So there's a huge advance, and the reason it's so important to the internet computer is it allows these different subnets to interact with each other without having to trust each other. They can just check the, chain key signature on the responses to their requests, and this basically is the bedrock, if you like, of the internet computer's capability.
So one of the concerns some people might have is that the way the token utility of ICP is designed, that there could be some centralization of governance initially, since if you stake your token, like to put it simply, the rewards kind of grow in proportion to the length if it's staked, and the team and the foundation, when they lock the token, they can basically propose some things that they want to kind of push through. So do you have any kind of rebuttal for this argument?
Well, there's two parts to the answer to that question. The first is that there's actually a pretty broad distribution of those ICP tokens. So, that seed round that took place in February 2017, for example, accounts for the biggest tranche of ICP tokens. It's about 24.97%, about 25%, a quarter of them. And, then you've got investors who come in other rounds and so on, and team members and the foundation. And, a great deal of care was taken before the internet computer underwent genesis to make sure that, no single party controlled the network nervous system. And not only that, the Dfinity Foundation, which has a reasonably large endowment, actually doesn't participate in most votes, and the reason for that is it doesn't, is terrified of legal liability. So for them, this really is a community-run system, and it's literally digital democracy in motion. You can see it evolving daily, and go onto the Discord and see people debating the different proposals and ideas. And naturally, that comes with accompanying politics. There are whales who hold large amounts of ICP that are very interested in the goings on and wanting to make sure that the right proposals are adopted and so on. But it's been working, extremely well. What is true, though, is that, really it's voting, all staking really is voting by capital. And the network nervous system, remember, is very different to proof of stake. It's not anything to do with enabling validator nodes to join the network and participate in consensus. When you stake a neuron, you're participating in governance, and the governance controls the network. The node providers, if you like, the parties that provide the computing power by running these special machines, but they're slaves to the network nervous system. There's a slightly different architecture to other blockchains. Now, if you look at proof of stake, though, the number of validators you can actually run, or more like the number of blocks your validators can produce, is directly proportional to the amount of tokens that you're able to stake. So really, it's voting by capital. And there are arguments for it. There are lots of good things about voting by capital. I mean, people who've got a lot of tokens invested obviously care very much about the network, and I can tell you that there are some major whales that I know of from the seed round that have never sold a single ICP. They've staked it all, and they're long term. Then they're here for the long term, and they believe in the network. And they've got so much capital locked up. Guess what? They really care about the network, and they spend a lot of time evaluating proposals and so on. So there's lots of good things about voting by capital. However, the internet computer ecosystem is probably going to be the first one to actually move things a little bit further in the direction of one vote, one person, one vote. So if you like, there's a slider, right? It's a spectrum. At one end of the spectrum, you've got voting by capital. Other end of the spectrum, you've got proof of personhood, essentially one person, one vote. And at the moment, every blockchain is at this end of the spectrum. It's voting by capital. What we want to do is to move it sort of along the spectrum. So, it's not only voting by capital, but it's also, individuals who've proven personhood actually get some additional voting power and some additional rewards. So that's another side subject. But in the next few weeks, hopefully, we're going to launch virtual people parties that will make it very, very easy. It's a very important innovation in crypto, actually. It's going to make it very, very easy for people to anonymously prove personhood. So, you'll be able to, get a neuron in the nervous system and then prove that it belongs to some anonymous individual, a discrete human being who's out there somewhere. And that will actually boost its voting power and actually the voting rewards it receives. And that's coming. And it's probably beyond the scope of this, this podcast today, but there's a post up there on Medium, and it's a very, very interesting subject. And it will prove revolutionary because until now, no one's known how to run these people parties or where people can prove personhood at scale, because people always imagine it has to be done with a sort of physical party. We found a way you can do it virtually. We were actually able to run people parties with billions of participants potentially. And that's a real game changer in the world of proof of personhood. So it'll be another internet computer first. And once that happens, you're going to see, the voting of the network inside the network nervous system move along that spectrum from purely being voting power purely being derived from capital towards one person, one vote, where anonymous individuals are able to prove personhood and increase their voting power and increase their rewards, which is super, super exciting because, of course, these same techniques that we're making available could potentially one day be applied within general, democracies, not just digital democracies, and be used to implement things like UBI, universal basic income, very efficiently. So if someone's interested in that, if listeners interested in that, they should go to I think it's called the Internet Computer Review on Medium, and there's a post on PeoplePod is there that'll explain it.
Yeah, this is certainly very insightful. Also kind of clarifies some FUD in the market. One thing I wanted to touch upon and maybe decode with you is your vision with regards to blockchain singularity. So can you just tell me more about it? What timeline are we looking at, and what are some of the steps that Internet Computer Protocol has kind of taken in order for us to go into that direction?
So, as you might guess, about someone like me who's dedicated his life to crypto and has been working on this kind of stuff for many years now. We're a blockchain maximalist organization, and our mission has always been what we call blockchain singularity, which is creating a blockchain that's so powerful that eventually, people build all of their systems and services on top of it. And we believe this is kind of inevitable. And it can be a multi-chain universe too, sort of, a Web3 universe where different networks and centralized services interact. Although we want it to be possible to build just everything on one blockchain without any kind of other moving parts, because it simplifies building things. Now, all things being equal, let's just say the blockchain was exactly the same as Amazon Web Services. It's not, of course, it's much better. Building with smart contracts is a far better way of building systems and services. But just say, for sake of argument, that this internet computer provided exactly the same functionality as Amazon Web Services. Well, we would claim that in the end, businesses would prefer to build on the transparent public network than become captive customers of, a monopolistic big tech organization. Because once you've built on something like Amazon Web Services or Google Cloud or Microsoft Azure, that becomes your immovable foundations, and your organization's infrastructure is pretty much stuck there. And there have been various efforts to make it easier to move from cloud to cloud, but they only give you so much. So we think that all things being equal, businesses and other organizations and entrepreneurs and everyone else would much prefer to build on a public network than a sort of private network. And that's very similar to, the reasons are very similar to those for, America Online and CompuServe or Microsoft's information superhighway versus the internet. And we've seen this play out before. For those who've been around for a long time like me, they'll remember the arguments being made during the 1990s by some people, like, America Online and CompuServe and Microsoft's information superhighway idea, are going to provide a sort of sanitized walled garden where all the content is curated. And that's going to be much safer and preferable for users than this big, bad, dangerous internet. Now, we all know how that went. And, the internet absolutely was a terrific route. And the internet was very clearly victorious. There are lots of reasons for that. I'll give you one example. Mehdi, imagine you created a website and that online dating was profitable early on. So you created an online dating website. I created an online dating website. And, we're competitors. What the internet did was prevent me from phoning up the owner of the network and saying, hey, I'll give you some stock in my company if you slow down, network access to Mehdi's website. And that was so important because it created a level playing field for everybody, a permissionless free market where anyone could create a service and nobody could switch you off. And that laid the foundations for all of this innovation and entrepreneurialism and economic growth and social freedoms. And, I think all of us would agree it's a very good thing that we took that fork and that society built on the internet, rather than some kind of private network where whoever owned that private network would be king. And the same arguments, of course, apply to traditional IT versus blockchain. We want everybody to build on a public network. And that's one of the things that was missing. The internet provided connectivity, but it didn't provide a compute platform. So we're extending the internet so that it can also act as a platform where people can actually run code and store data. And I'm very sure that all things being equal, if people would always choose to build on the open internet. But the good news, what's so exciting, is that it's not equal at all. Like smart contracts, what we call smart contracts, and which might better be described as just blockchain code. On the internet computer, they're called canisters for a bunch of reasons, has these absolutely revolutionary properties. So we all know that when you write blockchain code, that it runs on a public network. But there are other really cool things about it. For example, it's tamper-proof. That means you don't need a firewall. So, people have built, all kinds of things on the internet computer already, social media services, that kind of thing. And those systems are just running straight off the blockchain. There's no firewall to protect them. When you consider that the world will spend, I think this year, about $172 billion on cybersecurity, you can see the way that's a pretty cool feature that you can just build, and it's tamper-proof. You don't have to worry about someone hacking in and getting backdoor access. This is absolutely fantastic feature of blockchain code. And we all know what happens with traditional IT when it goes wrong. I mean, last year, the Colonial Pipeline hack resulted in, the oil pipeline that takes oil from sort of places like Texas to the East Coast stopping working. And then the refineries ran out of gas, petrol, and the fuel pumps ran dry. And there was like huge tailbacks of people at the gas stations and mothers in their car with toddlers trying to get back home. It's awful. So the world really needs to move on beyond that kind of those kind of problems that exist with traditional IT, and blockchain code provides the solution because you don't even need a firewall. It's tamper-proof. Another great thing about it is that it's unstoppable. The internet computer has been designed so that it can withstand a nuclear strike. It's distributed all over the world. And so it's very, very resilient. As long as the internet's running, it'll run. As long as you've got internet access, you should be able to access code on the internet computer, systems and services on the internet computer. And again, that's great. If you build on blockchain, your systems and services will always be ticking like the internet. Another one is it's very easy to build. These services are composable. I mean, you can essentially compose running services in the same way that you can build software from components. And that's actually very revolutionary. Tokenization means you can process things like data and identity in code. And most importantly for Web3, you can create autonomous code. Autonomous code runs without an owner. And it can either be code that can't be modified, or it can be code that can only be modified by a community DAO, which typically be controlled by thousands of, anonymous people over the internet, just like the internet computer itself is. And that basically means you could, create for example, a modern social network that, where the user isn't just the product that is used to sell advertising, but is also the owner, and the users are also the owners and the team.
Yeah, I just wanted to touch upon this point. I know internet computer has a vibrant ecosystem, especially when it comes to social media apps. So can you just tell me more about the whole ecosystem, like some of the projects that have already been built, or some of the projects you're excited about in the near future that are being built by the community?
Well, I mean, the ecosystem is growing so fast, I can't even catch up. I mean, I think, there were more than 1,000 developers building, a few months ago. I haven't got the latest numbers, but I now know it's in the thousands. So it's growing, pretty fast. It's an organic ecosystem. So a lot of, blockchain networks create a lot of hype by directing venture capital funding to sort of lighthouse projects. They get a lot of media coverage. And even across the board, they're paying all kinds of entrepreneurs to build using their blockchain. Sometimes, these projects will get millions of dollars in grants, followed on by millions of dollars from friendly venture capital firms that are really very related to the owners of the blockchain and so on. And then they get other venture capital firms coming in, and then all the press reports on and so on. We do give out grants to projects building on the internet computer. Generally, they've been very small this far, like $25,000, that kind of thing. Although we're beginning to give out bigger grants, like follow-on grants to projects that are really demonstrating potential. I sort of hesitate to call out projects. I think the one project I was close to personally and was OpenChat. I think that demonstrates the capabilities, but there are now a ton of really cool social media projects on the internet computer. Also, DeFi projects emerging using new functionality has been updated into the network recently. What's important about it and what's so revolutionary is that these services actually are running on the blockchain. And that's the difference between the internet computer, which is a world computer, and other blockchains. And I want to talk about some very important metrics that never appear in blockchain comparison tables. Okay, so the first one is, what does it cost to store one phone photo on the blockchain? So this is I think a really easy metric to understand. A phone photo is about 3.3 megabytes. So a gigabyte is like 300 phone photos. 17 minutes of phone video, 1/350th of all the blockchain, the Bitcoin transactions, and about 1/4 millionth of the data that's added to Facebook every day. So what does it cost to store one phone photo on a blockchain? When I ask people this, the numbers always way out. It costs you about $1 million on Ethereum, and the price goes up and down. But the price for a gigabyte of data on Ethereum tends to average about $300 million. So that's why it costs you $1 million to store a phone photo on Ethereum. Not only that, it's not even clear you'd be able to get it up there. You'd have to upload it in tiny little pieces. It would probably take you a week or two to get the phone photo up onto Ethereum. Solana, again, I'm not sure you can actually get the phone photo onto Solana, but the data would cost you about $2,666 today. On the internet computer, owing to the advanced mathematics and this completely sort of revolutionary blockchain architecture that it uses, and its ability to scale without any kind of limit and so on, would cost you 1.6 cents. So that, I think, kind of shows you why you actually can build on the internet computer. And today, when you hear people saying, I'm building on Solana, I'm building on Avalanche, I'm building on the internet, on Ethereum, sorry, it doesn't really mean that. What they mean is that they're building on Amazon Web Services, which is a, mega monopoly, big tech cloud service. They're building on Amazon Web Services, and then the cloud application that's running on Amazon Web Services is interacting with the blockchain when, for example, it wants to record the fingerprint of an NFT or move some tokens or something like that. But it doesn't really mean on. So, I think a lot of people have been sort of misled by that language. It's widely used in the industry that, I'm building on Solana, I'm building on Ethereum. It's complete nonsense. People are really building on the cloud, and then that cloud application is interacting with the blockchain via RPC. So one of the things we've found very difficult is to, convey that difference to people because of the language that's been adopted by the industry. But, the key metric is, what does it cost to store one phone photo on your blockchain? And when you think about an extraordinary missing metric, you see all these blockchain comparison tables, and they talk about TPS and transactions per second and number of validators and things like that. But they failed, they just completely omit this absolutely crucial number, which is how much does it cost to store data on the blockchain. And it really, that's probably the most illuminating statistic of all, because it really speaks to the efficiency of the underlying systems, network, and mathematics. And so you go from 1.6 cents on the internet computer to $2,666 on Solana to $1 million on Ethereum. So you can see why, you can't build social media on Ethereum or on Solana. It would just cost you hundreds of millions or billions of dollars just to have a few user accounts. And that's what we've changed. So there are some other really important metrics too. One of them is, can blockchain code service HTTP requests and essentially directly interact with users by serving interactive web experiences to them. And today, the only blockchain where smart contracts, canisters, blockchain code, whatever you want to call it, can service HTTP requests and actually serve web experiences directed to users is the internet computer. And obviously, if that's not possible, then you're again going to need to use the cloud. You're going to need or server machines to create a website that interacts with your blockchain via RPC. And the problem there, of course, if someone hacks the blockchain, someone hacks the cloud. Sorry, not hacks the blockchain. If someone hacks the server machine, hacks the cloud service or the cloud account, the users can have their token stolen. So for us, it's, again, very, very important that blockchain code can actually directly interact with users. And the way that happens on the internet computer involves chain key cryptography. There's some very clever cryptography going on behind the scenes. You can't see it, but ensures that the content that's getting into your browser actually really did come from the blockchain and hasn't been tampered with. So you put all these things together, infinite scalability, this incredible efficiency, which means that you can actually store significant data, user data on the blockchain itself. Web serving, so blockchain code can actually serve interactive web experiences. And several other features. We've got something called reverse gas. So, users can interact with dApps on the internet computer without first having to hold tokens. It uses a system called internet identity, which is very convenient. You can authenticate yourself anonymously in a way that stops you being tracked across dApps, just by using the fingerprint sensor on your laptop or Face ID on your phone, or if you want, an HSM like a YubiKey or a Ledger wallet. And you can, access your account on the dApp from multiple devices in this very convenient and highly secure way. So all of these, all of these kind of things, tend to be missing from blockchain comparison tables. Can users interact with hosted dApps without having tokens? Can the blockchain code serve web? So we're sort of campaigning for the these metrics we put in because we think they're very important. The problem's a bit like the one we'll face when some cars gain VTOL, vertical takeoff and landing capabilities. As soon as your car can fly, you need some new stats, right? You need max cruising altitude. Top speed isn't enough. What's the max cruising altitude? And that's kind of where we are, unfortunately. And people look at these blockchain comparison tables, just not getting the full picture at all. Even things like people talk about I think we're like 420 odd node machines hosting the network. There's another 800 as it turns, waiting to be integrated. And there's a lot of technical work going on to make it easier to integrate them, and they've just paused, building out more subnets until that's done. But each node machine basically has the computational capacity of a sort of 100 validators. So you get these tables as validators. Internet computer 400. Not really. If you want to get these dedicated, super powerful node machines and see what they and get an equivalent number for validators, multiplied by 100, more like 40,000 validators, right? And then when you got these, other node machines already, installed by node providers in the data centers being added to subnets, that's like, more than 100,000 validators. So there's a lot of, getting your head around the internet computer can be pretty tough because it's just very different. It has very, very different properties and very, very different capabilities to traditional blockchain. And the language that the industry uses is misleading. I'm going to build on Solana. No, what they really mean is I'm building on Amazon Web Services, building a cloud application that occasionally will interact with Solana, and all I'm storing on Solana is like a fingerprint.
So for investors who wants to value Internet Computer Protocol token, for example, do you think the correct comparable set would be cloud providers? Let's say if I were to value it, rather than value it against, let's say, Ethereum, maybe I should value it against, let's say, Amazon Cloud Service or Microsoft or Google Cloud Service. Would that be a correct analogy in terms of the valuation comparables?
Well, look, I think you mean to be very clear, the internet computer is a blockchain. It's just a blockchain that's grown wings. It's a blockchain where blockchain code can serve web, where efficiency has been increased hundreds of thousands or sometimes many millions of times. It's a blockchain where hosted dApps pay for their own gas, so users can interact with them without having tokens. So you don't need MetaMask, things like that anymore, and a whole lot of other things. Now, you can use the internet computer like you can use any other blockchain. If you want, you can just use it to manage some NFTs. But you can also use it for completely new things like building social media that lives entirely on the blockchain. The reason that's so important is that if you want to put a social media service under the control of a community, it has to run entirely on the blockchain, because the community will exercise its will through a DAO, Decentralized Autonomous Organization. Actually, we've got a special one coming in a few weeks that will make this very easy for dApp developers. It's called the Service Nervous System, which is using the same kind of technology you already see running in the network nervous system. And this will enable communities to control and manage services, whether it's DeFi service or a social media service, and whatever it is. And this is going to be very important because a DAO is constructed from smart contracts that are on the blockchain, and that DAO is only capable of updating other smart contracts, updating and configuring other smart contracts on the blockchain. A DAO can't reach out of the blockchain and configure an application running on Amazon Web Services for obvious reasons. Amazon Web Services needs a legal entity as a counterpart, a credit card details to be provided for the billing, and so on. A DAO can't do that. So a DAO can only, upgrade, configure, whatever, smart contracts that are also on the blockchain. So we believe that, this is the future of Web3, these mass market services that are running under the control of DAOs. We've got a special kind of super powerful DAO called Service Nervous System that's about to be made available through the actual, as part of the fabric of the internet computer, which is using the same technology as the network nervous system that controls the network. And once you do that, you can then introduce really interesting tokenization strategies. So I'll use OpenChat as an example because I'm very familiar with that project, but there are tons and tons of other projects. OpenChat is actually a chat service that runs from the blockchain. So when people are chatting, those chat messages are actually being processed and stored by smart contracts, called canister smart contracts on the internet computer, which is an absolutely mind-blowing, that this is possible is an absolutely mind-blowing advance. It's tremendous.
Just to simplify it for our audience, can we say it's the Web3 equivalent of WhatsApp?
It is actually. I mean, anyone can find it at oc.app. So if you type in oc.app, you'll be forwarded. You have to use a browser. You'll be forwarded to this really weird-looking URL, which is basically coming straight off the internet computer blockchain. More friendly URLs will be supported, I believe, in due course. But for now, you'll see a very strange-looking URL. It's coming straight off the blockchain, and the experience it provides is very similar to OpenChat. And you can send your friends, media messages. I think maybe it's just images at the moment. I'm not sure about video, but that's probably coming. You can create group chats with large numbers of people. Pretty much do everything. And now it's very exciting, of course, that you can have a fully decentralized chat service that actually runs off a blockchain and is served directly into your browser without any cloud. But although that's exciting in itself, what's for me more exciting is that this makes it possible to reimagine chat. So very soon, OpenChat will fully decentralize by assigning control of all the smart contracts that are running, making that service exist right now, to a DAO, a service nervous system DAO. And at that point, it'll run under the control of the community, which will have, I imagine, after some kind of like sale of governance tokens or something, thousands of users. Now, once that happens, it really is running as an extension of the blockchain itself, and it can start using more advanced tokenization strategies. So what you'll see is OpenChat, which is pure social media at the moment, will become SocialFi. So it's going to blend DeFi functionality. And that means that users will be able to send each other tokens, ICP, NFTs, Bitcoin, Ether, using chat messages. And yet other functionality, things like for business, document signing and notarization and things like that. So OpenChat will also, if you have an account in OpenChat, it'll also start behaving, if you want it to, like a crypto wallet, in which you can send tokens to people via chat messages. And I think this is where, blockchain gets, extraordinarily interesting, because, you're going to see the nature of things that you're very familiar with, like WhatsApp reappearing and then changing and improving and becoming richer and more interesting. On top of that, once OpenChat is fully decentralized and running under control of the service nervous system DAO, really as an extension of the blockchain itself, it will start randomly airdropping governance tokens to active users. So, if you're online a lot, completely randomly, you won't be able to predict it. Let's say, for example, hey, Maddie, thank you so much for being a supporter and active user of OpenChat. We'd like to give you some governance tokens. Please quickly do this capture to prove you're not a bot. And you'll do the capture, and then great, here's 6 governance tokens. And then completely randomly, if you're still an active user, a few weeks later, here's 10, here's 20, here's 1, whatever. So these airdrops would be continually taking place on a driven by the random cryptographic randomness behind the scenes. And the aim there is, okay, can you imagine, the first 5 million users of OpenChat become owners, in a sense, of this next generation Web3 social media service. And that's obviously an advance from mega monopoly, big tech services like Facebook, where the user is really the product on a hamster wheel, who's consuming content, giving their interests away, that then allows Facebook to sell access, to advertisers, to the users. So, the users aren't just the product, really. I mean, maybe not even the product at all in these in the next generation of social media, but they're going to be the owners, which I think is a big advance. And then when they become the owners, they're going to become advocates for these very same services. So to give you an idea of why this is important. So, I spent the last 10 years in Silicon Valley, in a place called Palo Alto, big companies like, Google and Facebook and so on, who are kind of my neighbors, just a mile or two away in these big campuses outside town. I think Facebook at the moment is expanding its Bay Area campus into different locations, and they're looking to house about 65,000 people in Silicon Valley and the surrounding area, which is sort of called the Bay Area because there's this sort of San Francisco Bay there. And a lot of those 65,000 people will be in sales and content moderation and things like that. Imagine that a service like OpenChat can fully decentralize and give away governance tokens to the first 5 million active users, say, and enlist a good proportion of them as part of the advocacy team. That's incredible. I mean, it's a small army. And then consider, you can also introduce sort of systems based on game theory and algorithms that allow anybody to be a content moderator and earn money by doing it without there being a job interview and without there being a manager, because the system basically rewards those participating based upon how well they're doing moderation, which you can determine using algorithms. So this is, going to be a revolution, going to go from a situation where the user's the product on a hamster wheel, being created for them by, a big tech mega monopoly like Facebook, to a different kind of service where they're also the part owner of the service, and they're also part of the team, either as advocates or even, as moderators or something like that. So the whole thing, and of course, because of this fusion between social media and things like DeFi, you're going to see new functionalities. In this case, your chat account will also be a crypto wallet. You can send crypto with chat messages and sign documents and things like that, notarized documents. And the way that APIs, these are things that developers use to interact with different systems, can be created on blockchain, will mean that the ecosystem will be built out far more dynamically and collaboratively. And things like OpenChat will themselves appear within other systems, and other systems will appear within OpenChat. You're going to have lots and lots.
Talking about other systems, I wanted to discuss integrations with Bitcoin and Ethereum. So just tell us a little bit about what you're working on over there, and maybe some other projects that might be integrated later on.
Yeah, sure. So, I apologize to the listeners in advance because some of this is just unavoidably technical. But we did talk a little bit earlier about how the internet computer works and how these subnets are able to interact without trusting each other because of this new chain key cryptography that allows the blockchain to sign its interactions. And you can just check the signatures, not only to know that the interaction with the blockchain hasn't been tampered with, but also that the blockchain itself is running correctly. That's how the internet computer is already running. If you go to Dfinity.org and the how it works section, you can look into the exact workings, at a high level or at a low level if you want to see the, some of the cryptography related to, the low level cryptography and how that works. We're adapting that chain key cryptography so that the internet computer can create transactions on other blockchains, which is a pretty profound thing. So, for example, you'd be able to create a Bitcoin wallet on the internet computer, which, had Bitcoin addresses that people could send Bitcoin to. And you could log into that Bitcoin wallet using, internet identity, i.e. a fingerprint sensor, Face ID, whatever you want to use. And then you could send Bitcoin to other Bitcoin addresses without having a Bitcoin key pair, which sounds impossible until you realize that, at the heart of chain key cryptography is threshold cryptography. And that's how the blockchain is able to create signatures. So essentially, you can write code on the internet computer that generates Bitcoin addresses, asks for Bitcoin addresses. And then when you want to create a transaction related to that address, you just say to the internet computer, hey, can you sign this? And the whole blockchain signs it, which means that, essentially blockchain code on the internet computer, internet computer canisters, smart contracts, we want to call them, in a sense will be on the Bitcoin network. Like it's like grafting smart contracts onto Bitcoin. And this is very, very different to a trusted bridge that can be hacked. This code on the internet computer will actually have Bitcoin addresses. And when it can receive Bitcoin as a result of people sending it Bitcoin on the Bitcoin blockchain directly, and it can send Bitcoin to any other Bitcoin address, and it will move on the Bitcoin blockchain. There's no need for some kind of trusted bridge where you have to give your tokens to a trusted intermediary, like was it Wormhole ETH that just got hacked for 300 million, that took ETH from Ethereum to Solana and back. Now, there's more as well. So we're starting off with Bitcoin because we feel that's where crypto began in a way. And, I think there's an appetite within the Bitcoin community, or we'll see if there is, to, start creating DeFi on the Bitcoin network. But we're also going to integrate with other networks. And in a way, the internet computer can act like a kind of master chain where code can create transactions on any other blockchain. And another feature that's coming is called HTTP outcalls, and these are made via consensus. Essentially, the network's making lots of HTTP calls and making sure the results are the same. What it will enable code on the internet computer to do is to actually query other blockchains by talking to their local nodes. So, for example, you could create a beautiful user experience on the internet computer for Ethereum DeFi. And, you would access your account using a fingerprint sensor or Face ID, whatever. No need for MetaMask and key management or anything like that. Much more secure, much more convenient. And, the sort of front-end part of this blockchain dApp would create Ethereum addresses. And then, the code can create corresponding transactions that get run on the Ethereum blockchain and also query the Ethereum blockchain to see how it's been updated. For example, if you did some kind of DeFi transaction, you don't obviously want to query Ethereum and make sure that the relevant balance was updated. And this will be possible with, once we'll start with Bitcoin, then we'll do Ethereum, and then we'll start looking at others. Maybe we'll do it for Solana, Avalanche. This will mean that a lot of those blockchain, people building on those blockchains can actually, finally get rid of cloud computing and the centralization, censorship, and security risk that comes with that, and build on the internet computer blockchain. It'll also be possible to create multi-chain systems on the internet computer that interact with multiple blockchains. And so I'm very excited to see what people build with that. But step one, though, and it's not far off now, the developer preview of the Bitcoin integration has already been made available to people. People are already, developers are already working with us already. It's just going to be it's going to be a game changer when this arrives. And I think it's like many things. One of the challenges we face at Dfinity is how do you communicate this stuff? Mostly the Dfinity project today, at least, is R&D and absolutely enormous R&D organization. We're building out comms, marketing, business development, but we're behind the curve, and that's going to take a while. What we have got is blockchain's biggest R&D operation, which has been running for years, and we produce this absolutely extraordinary technology. Difficult to communicate because at the moment, as I say, it's like with cars. What do you do when cars start flying and they get VTOL capabilities? All of a sudden, you've got to, the tables that compare cars now need to include max altitude. That doesn't exist today within blockchain. The internet computer, if you like, has learned to fly, but there's blockchain comparison tables don't contain a row for how much it costs to store a phone photo on the blockchain. Can blockchain code serve web directly to users? Can users interact without holding tokens? Can they authenticate using fingerprint sensors? All that stuff's missing. And of course, the next stat's going to be, can code on your blockchain create transactions on other blockchains? Can code on your blockchain query other blockchains? Again, it's so alien. It's alien tech essentially within blockchain. It's going to be it's going to be difficult to communicate it. But I think people are going to start seeing these really interesting things appearing, like Bitcoin wallets that you can use your fingerprint, the fingerprint sensor to authenticate with, that appear in your browser that you can use on mobile and on your laptop, say, where you can. You have a Bitcoin address and you don't have any key material. You have to manage, and you can receive Bitcoin, send Bitcoin. That will probably be the first way people learn about it in the wider audience. But the technology behind this is so important. It's really, really groundbreaking, and it's going to make an entirely new sort of crypto paradigm possible.
Yeah. Before we conclude, I would like you to answer this. What are some of the narratives with ICP the investors are not looking at? And what would you say are some of the significant risks that could perpetuate with regards to ICP?
Well, okay. So look, you're asking a biased person, of course, but again, I'm not giving financial advice. I personally believe that ICP is massively undervalued. There were a lot of hiccups at launch. I mean, first I want to say, a lot of the stuff you hear out there is FUD, and it's organized by competitors, and you've got to be very careful when you're reading anything about the internet computer these days. There's literally armies of people who spread misinformation about it. It was funded originally by a public crowd sale, seed round in February 2017. Those people obviously done very well, like 1,000x up in 5 years. It's one of the best investment returns in history, probably. But, at launch, we kind of got a bit skewered. It wasn't an ICO. That language is completely wrong. The network underwent genesis May 10th, 2021, and that meant that existing allocations of ICP became liquid. On the futures markets, it had been sort of, gradually rising. Bitcoin was about $65,000 at the moment it launched. And, about a week before launch, FTX had started, listing ICP perpetuals. And, I think the activity looked fairly normal. And the day before Genesis, on the 9th of May, 2021, I think the price was 120, 130, 140, something like that, moving around, say $130. And then, Pacific time, Genesis was going to occur 10 a.m. on the 10th Pacific time. But at 1 a.m. Pacific time, all hell broke loose. And with absolutely huge volume on FTX, the price rose to $480. So basically increased 4x. And when the spot markets open, like, Binance and Coinbase and so on, the market makers, they just took the price on the futures markets. And then, it fell over the following 10 days, $104, I think, below, what the futures have been indicating. The problem with that was that, hundreds of shills from other projects, and we were defenseless. We didn't have, these pyramid shilling teams that often, rode around like soccer supporters on social media, either extolling the values of the project they support or sort of attacking other projects. We were literally sort of lambs to the slaughter. Hundreds of these people appeared on social media saying it was a rug pull. The implication being somehow that we'd set the price. Nothing could be further from the truth. I mean, look to FTX and what's behind that. And, very clearly, obviously, if the price goes up 4x in a few hours before it launches, very likely it's going to come back down again. But the narrative was, it's a rug pull. Dominic was selling billions of dollars of ICP. I mean, complete nonsense. I already told people that, everyone even related to me, even all those tokens, about 3% of my holding, since sale. I mean, I'm a believer in ICP and the project. I'm here for the long term. That's why I'm still here working away like crazy. So is everyone else. But the narrative went out, and then you had like posts on social media saying, the Dfinity team's fake. And that, that it only cost you $5 to create a fake LinkedIn, to buy a fake LinkedIn profile. And so, these 200 plus profiles on LinkedIn are fake. Then you had this thing called Arkham Intelligence, who came out with just like fake research. And somehow that got onto New York Times. And then you had, I won't go into it, but you'll see what happens. Interesting stuff's going to come out about a lot of this stuff. But then you had this Roche-Friedman class action, which is completely baseless, that just repeated a whole load of lies for its own purposes. And, I did a lot of damage to the price. We were down, I think, at 20. I mean, the prices are down anyway, obviously, but we're like $24 or something at the moment. And, there are about 500 million ICP now, with the voting rules have been paid since launch. It's still a very valuable blockchain, but I personally don't believe that. I think, it's a difficult market. I think the challenges for the project as a whole are getting the message out. After the internet computer launched, there wasn't a single article in the crypto press for 5 months until Coinbase came out with this article, which had me some kind of photoshopped like a clown and just talked about all these sort of dodgy things like Arkham Intelligence and the class action and so on. And I think, information is going to come out of all these things, and people will see what a bunch of baseless junk they are and who's behind them. It's very easy to see that the internet computer is not a rug pull. Everyone's still here working their asses off. We're still producing incredible new tech. We're working even harder than before, if anything. Anyone can see that the price was manipulated and sent from, 120, 130 up to 480 in the hours before Genesis, and obviously we had nothing to do with that. People can do their own research, but don't believe the trolls and shills on social media. It's just people from competitors who've been told what to say, because the internet computer is alien tech and it's disruptive. And when even without the blockchain press reporting on us, and that's an interesting thing in itself. The difficulties we had there, the community, and without spending hundreds of millions of dollars giving away grants to developers to build on our blockchain. You actually do build on the internet computer blockchain, but these other ones obviously building on cloud. Even without giving away hundreds of millions of dollars, just giving out these 25 grand grants, we've already got an organic ecosystem of thousands of people. Imagine what's going to happen when finally we break through all the FUD and the nonsense, and people see it for what it is. And when blockchain comparison tables start including the metrics everyone needs to know about, like what's the cost of storing one phone photo on the blockchain? Is it 1.6 cents? Is it $2,666? Or is it $1 million? And when people include metrics like, can blockchain code serve web experiences directly to users? Or is it possible to build, without building basically a cloud application that does the UX? When these kind of, can users interact with tokens, all these things, when these super important metrics start making it into blockchain comparison tables, when, one way or another, the press starts reporting more on the project, when all these horrible myths that are being created by competitors for the simple purpose of sort of suppressing this alien tech get blown apart, what's going to happen then? I'm very, very bullish and excited about the internet computer. But blockchain's a rough and tumble game. There's no doubt the internet computer project generally got very, very beaten up by, huge armies of people that have, got vested interests and rather worried about this revolutionary new blockchain. We got very beaten up. So I don't want to make any promises, but what I can tell you is that even in the current situation, the developer community is growing very fast. They're building extraordinary things. You just can't even build on other blockchains. And we're not slowing down. We're accelerating. And some of the most powerful features that imaginable really are coming and down the road and are going to be with us very shortly. Like integration with other blockchains at a network level, so that the internet computer code can create transactions on other networks using chain key, starting with Bitcoin, like the availability of turnkey service nerve system DAOs, so people can fully decentralize on the internet computer, which is the Web3 dream. I mean, if you read about the aims of Web3 and what it's about, basically it can mean nothing less than what already exists and only exists today on the internet computer. Full autonomy, internet services that run fully from the blockchain, at web speed, that can scale, where users can interact without tokens, and can just authenticate themselves anonymously using a fingerprint if they want to, which of course doesn't result in the fingerprint being sent, by the way, to the network. It's just activating the secure hardware on your device. All of that, that Web3 dream exists today on the internet computer, which technically is years and years ahead of any other project, and that gap is going to accelerate because we haven't slowed down. So I feel very bullish about the internet computer. I personally feel upset about the price. I don't like it at all, and we're all fighting to broaden awareness about the project, because we think that the information's not out there. And we want people to have the information. But, for us, it's not about the price as well. It's about the technology and supporting this public network that really extends the internet and driving towards our ultimate goal, which is, much bigger than just blockchain, blockchain singularity, having the whole world building everything on a public network. We want people, enterprises to stop building using the traditional IT stack. Forget databases and web servers and middleware and memcached and corporate cloud services and firewalls and everything else. Just throw that away and build using, smart contract technology on the internet computer. That's our aim. And, Dfinity itself is a not-for-profit foundation, doesn't have any members, doesn't have any stockholders. It has an endowment that it sells, and its mission is defined by a notarial deed. And essentially, it can do two things. It can do R&D. It wants to do as much internet computer R&D as it can. It's constantly expanding that, and it wants to advocate for for the world, for the internet computer and its usage by the world. And in that sense, it's a terminator. It doesn't care if it's doing, badly or well. Its purpose is defined by notarial deed, and that is to improve the technology and advocate for it, and collaborate with everybody else, making the internet computer a fantastic system.
Yep. Thank you. And thank you for the clarity. Before we conclude, are there any conferences Dfinity is hosting or is going to attend? So a lot of our community member, if they want to meet you or the team, they can perhaps come over.
Yeah, so there's a bunch of reasons. I personally haven't been so active. And years ago, of course, I almost attended every single blockchain conference there was. I was on the Ethereum circuit, which is like a sort of traveling circus. And we always, going from one place to another around the world and talking about blockchain and the technology. We sort of hit ourselves in the metaphorical garage for several years to build the internet computer. I personally will be sort of re-engaging with the world. And I don't know, I can't tell you when exactly, but, I'm going to start attending a lot more conferences. I was actually at Crypto Finance in Switzerland just 2 or 3 weeks ago. We're also looking at beginning to run some Dfinity events. So we often do run smaller events at conferences around the world, but we'll actually run a dedicated Dfinity event. We've actually just got a new research center in Zurich. So we've got research centers in Zurich, Palo Alto, and San Francisco. The biggest is in Zurich. We're keeping the existing one, but we've had to get some new premises because, since COVID, we've actually probably more than doubled the people here or something. And it's like a 5-story building, and we're going to start using some of these buildings to run events. So, the idea is maybe it'll be, like a giant, events will run alongside of like a giant hackathon, and we'll help people come here and find a place to stay and run it with very large numbers of people. And then, alongside that, there'll be just general talks and things like that. That's in the works. I can't give you any information yet because it's still early, but that is in the works. It's coming.
Thank you, Dominic. It was a pleasure having you on the 100X. Hopefully in the future, we get you on board again for further updates.
Thank you, Mehdi. Thanks a lot.